7.3, multiplying special products. If we have an example of x plus 3 times the quantity x minus 3, so we have two binomials multiplied together. And remember, I personally like the distributive property, the multiple distributive property, what I call, and it's kind of like FOIL. We're going to multiply the x first term by both of the second binomial, or how many ever there are in there, and then the second term multiplied by those same two. So there's going to be kind of four terms that are multiplied together, and x times x is x squared. Then we have x times negative 3 is negative 3x. And x3 times x is positive 3x. You see where it's going, why it's called a special product. And our last one is positive 3 times a negative 3, which is our negative 9. Now, if we think about what happens here, is that negative 3x and the positive 3x zero out. Now, I know a lot of people say it cancels out, but it zeroes out. And let's think about what really zeroes out. It's the middle term. That middle term that we had been looking at and is kind of the unique one. It's that one with just the variable x's, not the x squareds, not the ones with the, well, over here would be x to the 0 power. Are you thinking exponents? And so that middle term that has the x, and we can kind of think about, so middle term is zeroed out right there. And why is that? So if we think about why that is, and if we kind of look at our problem up here, where does the middle term come from? And that middle term comes from when we have our x multiplied over here to the last term that doesn't have an x, and the end term of the first binomial that has no x multiplied by a single x here. So what we're looking at, those two middle terms, is where that comes from. Now, why do they zero out? Well, they zero out because both of the binomials start with an x, so there's an x and an x at the beginning. Then we have a 3 and a 3 as our second term of each of the binomials. But so first off, we have to have the same numbers in those positions. But then what we also have to see is one is a negative and one is a positive. So when we think about that multiplying that middle to get that middle term, it's going to be the same terms, but they're opposites. So we can write that as a kind of a rule for mathematics using our a and b. So if we have a plus b times the quantity a minus b, then, we should go back and think about how to simplify this into a much nicer way to write it. So that middle term zero out, so we're left with x squared, and we're left with that 9 in the back. Okay, so it's going to be a binomial, but that middle term zeroed out because one was positive and one was negative, so that negative times a positive is a negative 9 at that end. So if we think about this, has a middle term that's hidden. That middle term, remember, is that 0x. So if we go back to our rule thinking about that, so how did that look? It looked like the first term, a, we square it, and then the last term, 9, came from that 3 squared. So the last term over here is b, and we'll square it. And the middle term, 0, or ab, was zeroed out because it was 0a times b. And we have a subtraction here because it's a negative times a positive here. So that is kind of our rule of kind of a quick way to kind of run that. Now, what happens though is a lot of people mix it up because it gets tricky at different times, and especially when you add it to more complicated processes, you kind of forget some of those things. So what are the key things? It's subtraction. You have to look at that subtraction right there. That's the key that we're looking for. And why is it subtraction? Is because it's got the same terms, first and second, but then there's a negative and a positive. So they look very, very similar, but the little detail is one's positive and one's negative. All right, so let's take a look at a couple of examples. More examples. If we have x minus 7 times the quantity x plus 7. So as I write it down, I'm thinking, oh, this is a special product because if I think about that kind of middle term that's going to come from the inner, some people like to call it the inner and the outer if we're thinking about FOIL, that middle term is the same, 7x, but opposite, because one's positive and one's negative. So I can think of like the first term is squared, so x squared. My last term is 49, because that's 7 squared. And they're opposites, so when I multiply my last term, it's going to be a negative 49. So there is our final answer. And what you want to do is when you're multiplying these is not just kind of run that rule, but think about that middle term, because sometimes we need that middle term and know that it's that 0. It's sort of like how I think about that in linear when we talked about the y-intercept when it was x is always 0. Sometimes we needed that 0 to talk about it, and so if we don't think about it ever, it doesn't come to our mind when we need it. So that's kind of that middle term here for quadratics is that same idea. All right, so let's look at another example of 3x minus 1. Well, let's make it a plus 1, and 3x minus 1 here. So if we think about that middle term, remember that middle term is going to 0 out because 1 times 3x is 3x, and 3x times 1 is 3x also. So we have the same middle term, but then I look at the opposite sign, so that middle term will 0 out because it will be the same. Now you can write out and do all the, like we did up here, and write out all the terms and then actually, cancel them out, 0 them out like that. But I know that we're at the level of mathematics that we can just we understand what's happening mathematically, but we have to be careful because we want to kind of do that process so that we're not skipping steps too much so that we're like making errors or we're changing the mathematics rules. We don't want to do that. So we want to really think about how the mathematics is going to work. So how I want to think about this one is I'm going to take that 3x and square it. Then I'm going to take the 1 and square it. And it's going to be a subtraction in the middle because that middle term, well, the end term is a negative because it's a positive times a negative, and that middle term zeroed out. So now I'll just simplify that to, that's my exponent properties. So 9x squared, and 1 times 1 is 1. Now the reason why I kind of wrote it this way is because when we get some more complicated first and last terms, because sometimes they get a little bit more complicated with x's and y's and z's and more fractions and decimals, and if we use our exponent rules, we can really think about what that number will be, and we can see that we have a subtraction in between those first and last terms. All right, so how about if we do a few on your own? So if you want to pause after I give you a few examples to do, so that would be 4, 5, and 6 problems. So we'll set up our binomials being multiplied together. So x minus 4 times the quantity x plus 4. B plus 10 times the quantity b minus 10, 2y plus 5 times the quantity 2y minus 5. So why don't you go ahead and pause, practice a few of these, and come back and see if we our answers match. All right, welcome back. So here we have x squared 16, and it's subtraction. Because of that term on the end term is multiplied, a negative times a positive is a negative. The second number 5 is b squared minus 100. And number 6 is that 2y squared, which will be 4y squared, and we have 5 squared, which is 25. And then because it's a positive times a negative, it will be a subtraction. Now notice how I'm talking about that. And when it got more complicated, I went to this a little bit more thinking like how it works. Because remember, mathematics, it gets complicated as we go further. And what's going to happen is we're going to have to go, right now we're going this direction. Well, we're kind of going through that way and down here to our final answer. But in our mathematics, we're going to be going the other direction. And that's where a lot of students have a lot of trouble because they're really good at going this direction because it shows them that's the multiply and that's it. So, but when you're kind of going backwards, we're going to end with this answer and start with this answer. And so, or start with this problem with a 4y squared minus 25, and we're going to go back to what we call the original factors of that binomial. So we really kind of want to think about it in the mathematical way that the structure is, not just calculate the answers. All right, so if we take a look at our next special product, that was what we call products of opposites. I forget what the name of it specifically. There's opposite something, but this is, I don't think of the names necessarily. They have names, you could look them up, but I think of them as how the mathematic works, because then once I have that, even when they get complicated, it's easier for me to get the right answer because I'm thinking mathematically what the math is doing. All right, so this is product of squares, perfect squares they call them. And we'll start with that x plus 3 that we started with before, but we're going to square it. So this happens a lot, especially like when you have not a rectangle, but a square, and you're finding the area. So if one side was x plus 3 and it's a square, the other side is x plus 3. So this is x plus 3 times itself. Now there is a little rule that we'll walk through it, and we'll use that later on. But it's thinking about what works here. What's the similarities to what we just did with the subtract, and one's add? It's, what is it? Oh, so it's x squared, and at the back we have, I got arrow happy. I kind of look at, there's an x squared and a 3 squared, so that pattern follows the same as that x squared and a 9. Now you would think that the middle term zeroes out, but it can't because there's a plus and a plus. So it's a little different, but it follows something very similar to it. That's why it's a special case. So let's look at what it actually is. So x times 3 is 3x for a middle term, and our other middle term is also 3x. So those two together, 3x and 3x, they're the same, except this time I have to add them together. So it's the same middle term like we did before, but before it zeroed out because one was positive and one was negative. Here we add them together, or mathematically, we double the 3x. So how we can think of it is 2 times that 3x by putting them together. And that's that kind of rule that we have for products of perfect squares. So what would that be as a final answer? X squared plus 6x plus 9. So that first and last term, it's now a trinomial. So this quadratic really, or trinomial, because it's not quadratic, I guess because it doesn't have an equals yet. We're just simplifying the expression rather than the equation. So we have the first term and the last term that are very similar to our subtraction one, but we're just doubling that middle term, that 3x. See that 3x right here, 3 times x. That middle term will be doubled rather than zeroed out. So the rule for that then would be if we had a plus b, that quantity squared, because we're doubling it, would be a squared, b squared at the end, and that middle term ab, because we'll multiply the a times b, that would be like here would be that 3x, we would have to double it. So it's the rule itself is a squared plus 2ab plus b, and they're both positive because it'll be that same one. Now, you ask yourself, can we do that with subtraction? And yes, we can. It follows that same thing. It's just a little bit, it has a different sign at the end. But let's take a look at what happens with that. So if we think about, let's do x minus 3, that quantity squared. So when we kind of come up with that, so we'll see, we have, to really think about how that works, I'm going to show my two products, and then I like my arrows, my distributive property, because I kind of know that it's really, but it's that I call it double distributive. So x squared, x times x is x squared, and now my middle term, remember, my middle term comes from my inner and my outer, my first and last. So, and I kind of think about it as, what am I multiplying x by? Because that middle term is going to be the x's. So that would be, a negative 3x. And the other one is also a negative 3x. So you notice how they're the same number. So it's going to be doubled. So that middle term will be 6x. And at the end, why did I put a plus? Negative times a negative is a positive, and 3 times 3 is 9. So it's a little bit different. You'd think that it would be minus minus, but it's not, because both terms have a negative, and we can see that here at the beginning. Both terms, or both factors, have a subtraction in there. So a negative times a negative will be that positive 9. And that middle term is negative still, because we had a negative times a positive, and then again a negative times a positive. So, and a negative plus a negative is a negative. So that middle term will be subtraction, and the last term will be positive. So if we think about the rule for that one, a minus b, the quantity squared, will be a squared, and it'll still be a times b doubled. It's still doubled, but what's different about the plus and the minus here inside our squared is that the middle term is negative for the minus, and the middle term is positive for the plus that are the products. And then the last b squared is both positive for both of those. So it's just the middle term that is either positive or negative that is different. And that's the rule. But when I do my mathematics, when I do my multiplying, I'm like kind of how I thought about this middle terms are always zeroing out for the plus and minus. I'm always thinking about, well, that middle term is going to be negative. So when I double it, it's still going to be that subtraction of that middle term, that minus for that middle term. All right, so now another example, one more example. If I think about a couple examples of this that we have. So, squared. So I'm thinking in my head, here's what I'm thinking. So you might want to write this down because some people make an error in this part. So it's always best to, it doesn't take that long, to maybe 5 seconds to write down the two products. And when we multiply it, once we see it, we can say, oh, it's y squared, and the middle term will be y and a y, so that would be 2y's plus 1 times 1 is 1, which is 1 squared. Oh, that was not easy. Now, if we think about another where they get a little bit more complicated, 2z minus 3 squared. So I'm going to write it down, and this I'm going to kind of think about it using the other one now. So there is a little kind of like, some people call it a trick, but really it's thinking mathematically what's happening. So because it's squared, we're going to have this same problem like we did over here. Now, where does that 4z squared come from? Well, it's taking that first term times itself. So we can kind of think of that first term as that number, that first a, which is 2z squaring itself. Now we can kind of think about the second, the b, which is minus 3. We're going to square that too. So it's a negative 3. So here's how I'm thinking about it. Negative 3 squared over here. Now, if I look at it over here, I can kind of see, oh yeah, it's negative 3 times negative 3. That's why I like writing it out sometimes when it's complicated, because you really get the right numbers and the right thinking. And so that's going to be a positive 9. But notice how we thought about the negatives with it. I put it with that squared because it's inside the parentheses, and that's how squaring exponents work. That negative is within that squared. Now the middle term, let's think about that middle term. That middle term comes from the negative 3 times 2z, and then, 2z times negative 3. So it's these two terms multiplied together. So negative 3 times 2z is negative 6z is that middle term. But remember, there's not, and here, this is the problem, is here it looks like just one of them. But remember, when we're thinking about over here, how many, and that's why I like this sometimes, is you can see the two of them. There are two of them, and your eye sees that. Here, you have to really think about those two terms. So if we're going to double that, that would be a negative 12z. And a lot of people will see it here. They'll put a step in with negative 6z here, well, for this one right here, and then this one right here will also be a negative 6z. So that's where that negative 12z comes into play, or comes about. Now, let's take a look at maybe a couple practices for you. All right, so I'm going to do 11, 12, 13, and 14. So w plus 2 squared, x minus 7 squared, 3y minus 1 squared, and 5z plus 4 squared. All right, why don't you go ahead and pause it, and then come back. Welcome back. So we have w for 11, we have w squared. The middle term will be 2 times w, and then we square that, which is 4w. And then this last term will be 2 times 2 is 4. Number 12 will be x squared minus, and then 7 times 2 is, or 7x times 2 is 14x plus 49, because negative 7 times itself is positive 49. 13 will be 9y squared for this first term, a positive 1 for the last term, and negative 1 times 3 is a negative 3y, doubled is negative 6y. Now notice the order I changed it in. I kind of did my first term, I did my last term, and then I doubled the middle to get the middle term. So a lot of times I kind of think that way mathematically because I'm doing the squareds first. So that would be 25z squared and 4 times 4 is not 8, it's 16, it's positive, and my middle term is going to be 20z. Ooh, and then don't forget I have to double it because there's 2 of them, because that's squared, it's 2, one in and outer, how people sometimes think of it. So that would be 40z. Now I have one more thing to talk about, because once we learn about both of them, sometimes what happens is people have a little bit of, they mix up both of those. So if we have, say, x plus 3 times x minus 3, so they think, can I just make that a simpler one? Because if I have x plus 3 times x plus 3, I can write that as x plus 3 squared. And those, so see how we're kind of going the other direction. Usually we start here with the squared right now, but we're going that way. And we can go the other direction too. So depending upon how we need to have, like what we need to think mathematically, we can go one way or the other. Now, some people think that, can't we just put those together? Well, what would that look like? Would it be a minus 3 squared? No, that doesn't work because that would be a minus 3. That would be one of these, x minus 3 times x minus 3. That would be our x minus 3 squared for that one, because they both would have to be minus because that's what that squared means. So some people, we have a symbol for the plus and minus. So can we do a x plus and minus 3? Well, not really, because what that says is if we have a plus and minus here mathematically, that would mean that is squared. So that would have to look like x plus and minus 3 and x plus and minus 3, which would technically be 2 of those. So really what we're saying here mathematically is x plus 3 times the quantity x minus 3 for that first one. And for the second one, we would have x plus 3 times x minus 3, which is not, well, there's a lot more going on there than, I don't think that is mathematically correct. So we will just have to go back and get rid of all that thinking because it was the incorrect thinking. So we cannot rewrite this in a simpler way. This is the only way that we can write that x plus 3 times the quantity x minus 3. There is no simpler way we can. When we have perfect squares, yes, there is easier ways to do it, but not when they're opposite signs.